So I posted a short itinerary in Slack. This morning we have Sean Cleveland, the PI of this NSF award. He's going to have some opening remarks, and then we're going to go straight into the presentations, etc. So I'll open up to Sean, who will open the showcase for today.
Right. Okay. Welcome everyone. Excited to see all the presentations from all of the students that have been working so hard over the last 6 weeks to learn some new skills, work with some different data, different technologies, and excited to see what they've learned and what they've built. So we're this is our first inaugural cohort of students for the um, NSF Strengthening the Cyber Infrastructure Professionals Ecosystem, so SCIPE, Cyber Infrastructure Pacific Professional Summer Immersion Program. So we're looking forward to seeing these 10 presentations from the students that have completed the full program. And uh, so I will let Alex and the students take it away. But yeah, we're very excited about this and look forward to another 4 years of similar programs after this.
Okay, thanks, Sean. So we're going to go straight into presenting these talks. Be prepared to share your screen, and good luck with everybody. So we're going to start with Anne. We're doing it alphabetically. So over to you, Anne. Please share, and then off you go.
Hello, everybody. My name is Anne, and I am an upcoming senior at the University of Hawaii at Manoa, and I'm majoring in mathematics with a concentration in data science. And my project for this immersion program is on D3 visualizations of Waikane stream and tide data for flood awareness. So for some background, the windward area of Oahu is prone to flooding, and these areas tend to have some road blockages and a lot of issues, especially because the Waikane watershed and Waiahole watershed stream heights tend to fluctuate during times of rain and hurricanes. And although stream and tide data is really easy to access, it's really hard to understand, especially for the community and just like common people. And although weather forecasts have can give information on flooding, they do have their limitations. As a result, the motivation of this research project is to create an app that is accessible for everybody, similar to the Hanalei app that is for Kauai. So in this app, we aim to help inform the community about flood risk, and so to inform them again about road blockages and any dangers around the area. And my personal job for this project is to create user-friendly visualizations so that people in the Waikane area can easily understand the severity of flood so that they can plan their trips and they would know where to go and avoid these road blockages. So that leads me to my research question, which is how can Waikane stream and tide data be visualized so that residents can easily understand the flooding status in their area? So for my data sources in this project, we mainly used USGS and NOAA. USGS for information on the stream heights of the Waikane and Waiahole streams, and then the NOAA API for the predicted tides of the nearest station, which is Mokuoloe. There isn't really a station here in the area of Waikane, so this is the one that we used for this project. So this data was found with a simple Google search. Just looking up Waikane stream height or Waikane predicted tides would easily get you to these websites. And when accessing these APIs, this data is retrieved as a JSON file, and then some code is created to convert them into pandas data frames. And as I said before, they're collected by accessing APIs. So this is like an example of like what would you see if you searched it up on Google. So to process the data, actually, I was working on this project with a couple other people, mainly Brian, Chris, and Kiara. And when we coordinated with them, Brian already had a Jupyter notebook file that can pull the data, organize the data, and analyze it. And my personal job was to create visualizations of that. But I made sure to read over the code and understand how it was, how it did that. So in order to process the data, these were the steps that the code did. First, pandas data frames were created with date, time, and measurement columns. And then from the data that we picked up from the API, we converted them from Moku'ole predicted tides to predicted tides for Waikane. And then we used that data to predict the high tides and the low tides. And we also determined the flood thresholds that we got from the APIs. So according to Brian, our personal supervisor, we use the USGS Stream Gauge API data to pull 15-minute water level data from the Waikane and Waiahole stream. And then we use NOAA Tide Gauge API data to pull said low and high tides from the Moku'oloi buoy. And then we calculated them for Waikane. And we created a sinusoidal curve so that it would look like a wave and predict the low and high tides that are upcoming. And then for the thresholds, we grabbed that from NOAA, and then we just translated it specifically for the Waiahole stream, Waikane stream, and the tides. So this is the data frame that would be immediately retrieved from the USGS website. So nothing on, not a lot of cleaning was done here. It was just directly grabbed from the API. And then this is the predicted tides that we would get from the NOAA website. But again, this is for Moku'oloi. So we had to do a little bit of organizing and cleaning to convert this data for Waikane. So this is the code right here. A lot of a lot is written here, but and then this is another one. So this mainly was to find the high and low tides. And this code right here was to make the sinusoidal curve. And from that, from the Moku'oloi data, we were able to translate that into a data frame for the sinusoidal curve, which is the Waikane tide curve, and then high and low tides, which is the Waikane tide data, as you can see from the type L for low tide and H for high tide. And then these are the thresholds that we obtained. So for the tides right here, it would be from -2 to 1 feet would be no flooding, and then 1 to 1.87 feet would be minor flooding, 1.87 to we made it 3 would be major flooding. And then this is for the Waiahole stream. 0 to 12 would be no flooding, 12 to 16.4 would be minor flooding, and then 16.4 to 22 feet would be major flooding. And then for Waikane, the no flooding would be 0 to 7 feet. And then 7 to 10.8 feet would be minor flooding. And then 10.8 feet would be, 10.8 feet to 16 feet would be major flooding. So for the data visualization, my part of the job was to create gauge charts and line graphs using the React app for the Waiahole stream height, including the last 2 days, Waikane stream height, including the last 2 days as well, and then Waikane predicted tides above the mean sea level from the day before to the next day. So in order to visualize the data, these were the steps that I did. First, I created a backend using Flask to run the Jupyter Notebook. So the Jupyter Notebook that Brian created had the data frames already, but I just added some code in order to generate JSON files of the data frames that he created. And then the Flask server would provide REST API endpoints that read the generated JSON files, served as HTTP responses to the front end. And then for the React components, for the gauge chart and the line graph, I used fetch calls to obtain the data and display it on the said graphs. And then the gauge charts and line graphs update every time the site is refreshed. So this is what I ended up having at the end of the program. So this is for the Waiahole stream heights. That shows the thresholds right here. And this is also the graph that could be toggled for the stream height and the latest reading. Same for the Waikane stream height, which has different thresholds but serves the same purpose. You can toggle as well for the stream height and latest reading. And then this is for the Waikane tide level, different thresholds once again, but can also toggle for high tides, low tides, the latest reading, and the tide curve. And then the latest reading would be the triangle right here. So it can predict future tide levels right here. So for our next steps for this project, currently what we have right now only works on the local host, but we are planning on deploying the website to the public so that the residents in the area can access it freely. And I also plan to make the website operate a little bit faster because the way that I created the back end is tends to run a little bit slow. I could also clean up the notebook a little bit so that it would only run specific types of code at specific times. And we also plan to add other features such as wave conditions, amount of rainfall, and current news, possible blockages around the road so that people can plan their trips better. We also Me and Brian also had a presentation at Kupuna Breakfast with the Key Project this morning, and the residents suggested that we should add hurricane prediction data as well. So we might plan on adding that as well. And then we also think about making it into a mobile phone application so that it can be easily installed by the residents in the area, and then they can just open up the app on their phone and see what's going on. And since the only basis we have is the Hanalei app, and hopefully this one as well. We would like to apply this code to other flood prone areas so that they would have their own flood awareness app as well. So for my reflections, the main thing that I definitely realized is that data will appear confusing at first, but having goals and like figuring out what you need to do definitely helps with that. And data can also be visualized in many ways. At first, I only worked with line graphs before, and working with a gauge chart this time was very informational. And a lot of my code didn't work throughout the process, but perseverance is definitely key. And don't be discouraged to ask for help because you may not know everything, and that's okay. And it's always all right to reach out for help. For future goals, I would like to continue working on data science projects such as this one. So hopefully I can work on this project more after this program. I would also like to expand more of my skills for in data science, data visualization and stuff. And I also want to create meaningful connections and network with a lot of people and learn more from them. I also would like to obtain my master's in data science and possibly either work in industry or academia, doing research, or maybe some field in healthcare or government. So for my acknowledgements, I would like to thank Brian, Chris, and Kiara for working on this project with me. I'm really satisfied with the final project for now, but I'm also excited for what's come to next. I'd also like to thank Sean Cleveland for presenting the project idea initially during the first few weeks of this program, and Dr. Alex Stokes and the mentors for continuously guiding us throughout this um, summer immersion program, and the Hawaii Science Institute for providing us with this opportunity to learn something new. Thank you.
Awesome. Are there any questions? Okay. Not seeing any questions.
So, did you get this running on anything other than your local machine when you were trying to do some Flask development? Did you?
We did get it working. However, it was running really slow. So the website can be accessible, but it doesn't really load data yet. So that's what we're trying to figure out for now. But does run on the local host for sure.
Okay, very nice.